In this part and the next parts, we will conduct the hydrologic modeling using the HEC-HMS program or Hydrologic Engineering Center Hydrologic Modeling System using the input file prepared in the advance by HEC-GeoHMS in the ArcMap, and the method of preparing it is explained in the previous parts of a category or within the playlist entitled HEC-GeoHMS, in which the input file was prepared with the HMS extension for the study area, which is located in this file under the title HEC-HMS, which contains the input file titled laserzap.hms, which will be used in the HEC-HMS program to conduct the hydrological modeling. The hydrologic modeling system HEC-HMS is designed to simulate the complete hydrological processes of watershed systems, including many conventional hydrological procedures such as infiltration, unit hydrograph, and hydrologic routing, as well as a procedure for continuous simulation including evapotranspiration, snowmelt, and soil moisture calculation. Network flow simulation can also be performed, and supplementary analysis tools are available in the program for parameter estimation, distance to length analysis, flow prediction, uncertainty assessment, erosion calculation, sediment transport, and required water quality. The water feature and integrated work environment with the data entry tools, a calculation engine, and output reporting tools. The graphical user interface allows a smooth transition between the different parts of the program, and the simulation results are stored in the HEC DSS data storage system and can be used in the conjunction with other programs in studies related to water saving, urban drainage, flow forecasting, future urbanization impact, reservoir channel design and damage reduction, flood regulation, management and operation of systems. And the following is an explanation of how to conduct hydrological modeling in the HEC-HMS program as follows. In which the input file was prepared with the HMS extension for the study area, which is located in this file under the title HEC-HMS, which contains the input file titled laserzap.hms. We open the HEC-HMS program and in it we go to the tools menu, then we press on the program settings, and in it we go to the defaults menu, and in it we specify the options as we see. then OK. Then we press on the Open a Project, then Browse, Desktop, hit HMS, then we press in the input file titled laserzap.hms, then we press on Convert Project, then the project file titled laserzap is opened in HMS program. Then we go to the Bayesian models and we press on the project file titled laserzap. Then the diagram for the project of the study area Bayesian appears. Then in the Bayesian model, we specify the options as we see. Then we go to the View menu and we press on the map layers. Then we press on Add. Then we add the subbasin1.shp. Then we add the river1.shp. Then we choose subbasin 1 layer. Then we press on Draw Properties and we make transparency 100%, then OK. Then in the project titled LaserZap, we have the watersheds, dams, junctions, and reaches. First, we go to the watersheds and we click on the first watershed. Then in the subbasin menu, we specify the options and we choose the methods according to the chosen methods that prepared in advance by HGeoHMS in ArcMap, as we see. Then we go to the loss menu and in it we find all the values was calculated in advance by head GeoHMS in the ArcMap. Then we go to the transform menu. In the graph type, we choose the standard PRF 484. Then we need to calculate the lag time in minutes, and to do so we need to open the project file that prepared in advance by HEC GeoHMS in the ArcMap. So we go to the desktop and we delete the old project file titled LaserZap. Then we bring the project file that prepared in advance by HEC GeoHMS and the ArcMap, which is inside the project file titled LZRB project. Then we copy the project file titled LaserZap. Then we paste it on the desktop via paste. Note, in addition to this project file titled LaserZap, we need also to add the other associated files which already exist here on the desktop in the project file titled LZRB project. Then we open the project file titled LaserZap, and in it we open the project file titled laserzap.mxd in the ArcMap. Then in the ArcMap we open the table of the subbasin 1 layer. And in it we find that the lag time is not calculated in the basin lag field, and to calculate the lag time we need to calculate curve number Cn in the basin Cn field. To do so, we go to the fifth menu from the GeoHMS menu bar, which is parameters. And in the parameters menu, we press on the select HMS processes. In input subbasin, we choose subbasin 1. In input river, we choose river 1. In the subbasin loss method, we choose SCS. And we leave other options as it is. Then we press on OK. Then close. Then we return to the parameters menu. Then we choose subbasin parameters from raster. And in it we go to the input curve number grid. Then we choose CN grid. Then OK. Then the curve number calculation process begins. Then close. Then the curve numbers for the subbasins of the study area basin appear in the basin CN field. We note that these curve numbers contain decimal numbers and are slightly different from the curve numbers in the CN grid layer, which are integer numbers. And the reason for this is that the subbasin may contain more than one curve number. So here the value of the weighted curve number is calculated in each basin. Now, after we calculated the curve numbers values for the subbasins in the study area basin in the basin CN field, we calculate the values of the basin lag. To do so, we return to the parameters menu, and in it we press on the CN lag. Then a message appears indicating that CNLAC successfully completed, then OK. Then the values of the lag time in hours appear in the Bayesian lag field as we see. Then we transfer the Bayesian lag field beside the name field as we see. Then the name of the first subbasin is W2560. So the basin lag is 17.6 hours. So we transform it to minutes by using the calculator as we see. Then the lag time is 1057.74 minutes. So we go to the lag time and we type 1057.74 for the first subbasin W2560. Then we go to the basic flow menu. In the initial discharge in meter cube per second, we type 50. In the recession constant, we select the value that was pre-calculated in the previous parts inside the Excel file titled Results of Calculation of the Constant Recession and Related Parameters. And in it we have the calculated recession constant for many months. So we calculate the average of them as we see. So the average value is 0.885. Then we copy this value. Then we return to the HMS program, and in the decision constant we type the value by Ctrl V. Then in the threshold type we choose a threshold discharge. Then in the flow in meter cube per second we choose the value that if the discharge becomes less than it, there will be no flow, so we choose 1. Then we go to the options menu, and in it we can enter the observed values, but we do not have observed values in this subbasin, and it is optional, so we leave it as it is. By that, we have finished entering parameters for the first subbasin, and we will continue the implementation in the next parts.